Now that we know about different types of variables and how to collect data, let's look at the ways how to organize and analyze data. When you go to a fast food restaurant, what features are you looking for besides good food and affordable prices? Right, the speed of the services. That's why they call fast food restaurants, that the service is provided fast. Let's say we measure service times in seconds from a sample of a drive-through customers at a certain McDonald's restaurants, the data presented in the following table.
It is really difficult or nearly impossible to tell what is the average or mean drive-through times from this table. We want to organize data in the frequency table to be able to analyze it easier. Before we do that, let's learn some definitions related to frequency distribution tables, which is a table that shows how data are divided among several categories called classes by listing the categories along with the number of frequencies or occurrences of data values in each of them. Here are some of the examples of the frequency distribution. Frequency distribution table have classes that can be listed as interval or a single digit or a category. The class listed as interval has lower and upper class limits. The lower class limits are the smallest number that can belong to each of the different classes. For example, in the first one, it's 2.4, 2.5, 2.6, and so on. The upper class limits are the largest numbers that can belong to each of the different classes. In the first table, it's 2.49, 2.59, 2.69, and so on. The class width is determined by the difference between the two consecutive lower and upper class limits. For example, in the first table, the class width is determined by subtracting 2.4 from 2.5. We also need to know some more definitions. The class boundaries are the numbers that used to separate the classes, but without the gaps created by the class limit. If you look at the first table, we can see that between 2.49, the upper class limit of the first class, and the lower class limit of the next class, 2.5, there is a tiny gap. We want to close that gap. That's why we create a class boundaries, and we will learn how to do that. Class midpoints are the values in the middle of the classes. Each class midpoint can be found by adding the lower class limit to the upper class limit and dividing the sum by 2. For this data set, we are going to divide the data values into 5 classes. Usually the number of classes is between 5 to 20. The number of classes depends on the size of the data set. The larger the data set, the more classes you probably want to apportion it into. To determine the class width, we divide the difference between the maximum and the minimum data value by the number of classes we would like to have. The maximum data value in this data set is 308 minus the minimum 83 divided by 5, number of classes that we chose to have equal 45. Let's round the result to get a convenient number. Next, choose the value for the first lower class limit by using either the minimum number of classes or a convenient value before the minimum. We're going to choose the minimum value for the first class, 75. Since the lower value is 83, we want to go a little bit lower. Using the first lower class limit and the class width of 50, list the other lower class limits by adding the class width to the first lower class limit. 75 plus 50 is 125 plus 50, and so on for the rest of the classes. Now let's list the upper class limits. The upper class limit will be a little bit less than the next lower class limit. The first class is from 75 seconds to 124 seconds. Second class, 124 seconds to 174 seconds. Notice that the upper class limits also different by 50. Now let's count the data values for each class. From 75 seconds to 124 seconds, 1, 2, there are 11 of the values between 75 and 124 seconds. Next class will include the values that fall within 125 to 174 seconds. Let's count them. 1, 2, 3, 4. There are 24 of those values between 125 to 174 seconds. Let's continue filling out the table. There are 10 data values between 175 to 224 seconds and 3 values between 225 to 274 seconds and 2 values between 275 to 324 seconds. Now let's build another variation of frequency distribution, cumulative frequency, in which the frequency for each class is the sum of the frequencies for that class and all previous classes. First class will be 11, the next is 11 plus 24, 35. The next is 35 plus 10, 45 plus 3, and finally 48 plus 2. At the end, we should have all data values counted. If we don't have all 50 of them in this case, for example, we have 48, that means that we missed 2 data values somewhere. Or if we have 52 or 53 or 51, that will mean that we overcounted one or more of the values. Now we're going to build relative frequency, which is another variation of basic frequency distribution in which each class frequency is replaced by relative frequency or proportion or percentage. Find each class relative frequency by dividing the frequency by the total number and multiplying by 100%. The sum of the percentages in a relative frequency distribution must be very close to 100%. Earlier, we noted that a frequency distribution can help us understand the distribution of a data set, which is the nature or shape of the spread of the data over the range of values. In statistics, we're often interested in determining whether the data have a normal distribution or a bell-shaped distribution. Normal distribution is when the frequencies start low, then increase to 1 or 2 high frequencies, and then decrease to a low frequency. We will now construct a histogram to help us better see the shape of the distribution of this dataset. A histogram is a graph of frequency distribution, where frequencies displayed as bars adjacent to each other. The horizontal scale represents classes and vertical scale represents frequencies. The heights of the bar correspond to frequency values. When we build the histogram, we use class boundaries instead of class limits to avoid the gaps. First, we don't start with the 0, so we're going to put the zigzag. The first class is from 75 to 124. Let's see what happens. 124. Next class starts with 125 to 174. Between 124 and 125, there is a gap that we want to close. So we create a class boundary by adding the lower class limit to the upper class limit of the next class. 124 plus 125 divided by 2 is 124 and a half. Next class boundary will be between 174 and 175. It will be 174 and a half. The next class boundary will be between 224 and 225, which is 224 and a half. And finally, 274 and 275, it's 74 and a half. And lastly, since we moved the boundary from 275 to 274 and a half, we basically moved it a half a point to the left. We need to keep the class width the same, so we need to move a half of a point to the right, the upper boundary as well, 324 and a half. The same will happen with 75. It becomes 74 and a half. Since we moved the boundaries on the right, we have to move it on the left as well. The frequencies will start with the 0. We have maximum of 24 frequencies, so we go by 5. 0, 5, 10, 15, 20, 25. Now let's raise the bars of the classes. The first class frequency is 11. We raise the bar to 11, which is a little bit more than 10. Next class frequency is 24. Next is 10. Next is 3. And the last one is 2. This is a histogram that shows the distribution of our data. We can also connect the tops of our bars by connecting the midpoints. The class midpoint is located between the lower and the upper class limit. To find the class midpoint, add the lower class limit plus the upper class limit and divide it by 2. Now connect the midpoints. Now we can clearly see the distribution of our data. It has almost normal distribution but a little bit skewed to the right. Before we looked at normal distribution that has a bell-shaped curve. Skewed to the right distribution has a distribution that has a long right tail. Skewed to the left distribution is a distribution that has long left tail. That means that outliers are on the left. And then skewed to the right or positive distribution, outliers are on the right. We also have uniform distribution when data distributed uniformly. To easily remember the shape of the distribution, we can use a little trick. Imagine you're looking at your feet. Skewed to the right distribution looks like your right foot. Skewed to the left distribution looks like your left foot. And finally, we can build a relative frequency histogram that will have the same shape and a horizontal scale as the histogram from regular frequency. But the vertical scale uses relative frequencies as percentages instead of actual frequencies. So for the first class, we will have 22%. For the second class, 48%, 20%, 6%, and 4%. From the shape of the distribution, we can tell where the most data are located and where is our mean located. We know that the mean waiting time of the drive-through service times for McDonald's lunches would be in the interval between 125 and 174 seconds because most of the data values located here. On the right, there will probably be some outliers, which in the next chapter, we will look more closely at how to build a box plot that will tell us where and what are the outliers. I hope you find this lesson helpful.